we use the digital right quite a few times, right? And what that's doing is, one is the digital, so it's associated with the digital pins. But when I say digital right and I say high right here, like this form of high, like how high I am, as far as high on a mountain, uh, this only thing this is doing, only thing this line of code is doing is taking that pin number, which we have established here, and it's setting it to 5 volts. So it's just sending a pole, or sending 5 volts of electricity out. Why 5 volts? Because it's an Arduino. All right. Most other microcontrollers you use are actually like 3.3 volts, or even less, depending on what system you're working in. But because it's Arduino, it is 5 volts of electricity. So whatever pin number is associated, when I use this pin number of 5, or let's just say I put a 5 there, and I say a counter of low, I'm saying I'm just sending out 0 electricity. While here I'm saying I'm sending out 5. Now Jay asked last class, and another person asked last class too, is there a way to make the lights fade? And that's what we're going to cover today. Now this topic here, what we're going to cover, is called pulse width modulation. All right, pulse width modulation, or PWM. All right, and what that is going to allow us to do is it's going to allow us to fade a light on and off. All right, just by using 5 volts. Now that's really hard to wrap your head around unless you see a video, or unless you see it in person and stuff like that. So I did find a good video of it. Where is it? Here it is.
You might have heard me talk about PWM, or pulse width modulation. In today's video, I'm going to go into more detail on what PWM is, and how you can build a PWM circuit that can dim lights, control the speed of a motor, or change the amount of power going to pretty much anything you want. So let's start with a description of the waveforms.
So the first thing I want to note out, he's using what's called an oscilloscope, or O-scope. Now what the O-scope does is it gives you an X and Y axes. All right, these are your axes here. Wow, horrible. It's actually up here. Right up there. So this axis here represents your volts. All right, and this axis down here represents your volts per time. So time. So what he's showing here now is about, looks like it's 10 volts. Yeah, it's close to 10 volts. It's 10 volts of electricity, and it's constant throughout. All right, so it has full power. That's what this oscilloscope is showing. And this gets to be a very important functionality as far as using these, as far as radios, TVs, all that stuff. Is a waveform is how you are actually able to hear me. Remember, sound and light are all waves. But here we're going to start using waves to do what we want them to do. All right, so let me erase that. Oops.
Here's what 10 volts DC looks like, and here's what 0 volts DC looks like. Now let's see what happens when...
So you saw that was up here was 10. Now we're going to be using the 5 volt system, but the concept's still the same. 5 volts, and then down here is 0, and it's constant throughout time. Wow, that was loud. Oh, Red Cross wants my blood. All right, those vampires. All right.
You have 10 volts being switched on and off. Right now you can see that the waveform is 10 volts half the time and 0 volts half the time. Since it's 50-50, we say that...
Where'd you see a robot at, David? Which robot are you talking about?
The waveform has a 50% duty cycle.
Oh, the voice. All right, so here is an actual pulse width modulation. And here, this is the same system. And here, in this, what it's showing that it is on for half the time and then off for half the time. All right, so, and this is, remember, all these are just times. And this is probably in the kilohertz. The frequency is kilohertz. You got 5. So this is probably in the millisecond range. milliseconds. So this is, I'm guesstimating here without looking at the other specs, that this right here is probably like 1 millisecond, this is 2 milliseconds, etc., etc. So it's a very short time frame. And so it's on for half the time and it's off for the other half of the time. And what that allows you to do, if I actually hooked up a multimeter, something that measures voltage, to whatever pin we were talking about, I would actually only read 5 volts of electricity because it's only half the time.
Since the 10 volts is only there half the time, what you end up with is an average voltage of 5 volts. Now let's change the duty cycle. Now the wave is only on for 10% of the time, so we say it has a 10% duty cycle. 10% of 10 volts is 1 volt, so we end up with an effective average of 1 volt. So you can see how by changing the pulse width, we change the average voltage seen by a circuit. We call this technique pulse width modulation. Now the easiest way to generate a waveform like this is with a function generator. But most people aren't going to drop $100 to get one. But that's not a problem. You can build a PWM generator circuit fairly easily, and all you need is a few parts that you can get from any Radio Shack. So here's the circuit diagram. The key component.
So now this is one way of doing it. This works. Using this whole complicated circuit, you got diodes and resistors, and you got all kinds of craziness going on here with LEDs and all kinds of stuff, and a capacitor. But we're going to simplify this process by just writing a few simple lines of code and make everybody's life easier. All right, so that's how. Does that make sense? Is the concept of PWM? Do y'all think y'all understand what I'm saying? So when it's off for half the time and on for half the time, I'm adjusting how much voltage is going through that particular pin, even though it's still 5 volts of electricity. But because I'm turning it off for a certain amount of time period, I'm changing the voltage in which it will read. All right, and that's what we're going to start covering today. All right, and this gets to be the reason we bring this up is, one, this is kind of like a little bit of advanced stuff, but this gets to be important when we start dealing with different types of sensors. Even though we're not going to be using any, but it does matter when you deal with motors. Like you might want a motor to go half speed. You don't want a motor to go full speed the entire time. So you use the concept of PWM to send a certain amount of power to the motor. All right. Now the only trick to it is you can't use digital write because, well, that only gives you a value of high or low. It doesn't give you anything in between. I could actually put a 1 and a 0 in there and it would function the same way. All right, so with your circuit still hooked up, we're going to kind of experiment a little bit with PWM. And the way we're going to do that is, all right, we kind of already covered all this stuff. Saw something happen over there. All right. And here's what we got. The PWM kind of fools your eyes to see that the LED is fading, but actually doesn't really fool your eyes because that LED only has that much amount of power. One thing about both motors and LEDs is they don't just go full speed right off the bat, or full brightness right off the bat. There's an exponential curve to both of them. One's inverse from each other. I can't remember which, but by shutting it off at a certain time, it never reaches that full potential or that full power that the LED is capable of or the motor is capable of. All right, so same circuit and new code. This is going to be, this will be your first code. Go ahead and type it out. Start typing it out as I kind of explain it a little bit here. There should be a semicolon right there. There it is. Just hiding it. All right. Now, in the beginning of the class, make sure you use these specific pins, because there's new program or new file, either one. So go to open up your Arduino, go to File, New, and start typing this stuff out. The PWM, there are only certain pins on your Arduino that are capable of doing the PWM. And those pins are the ones with the little squiggly marks on them. And there's only, 1, 2, 3, 4, 5, 6. Actually, I just realized something. I wonder if I take 2, raise it to 6. No, that ain't it. Eight. It's 2 raised to the 8 for some reason. Why is it 8? All right. That doesn't matter right now. All right. So where the digital write only gives you the capability of going from high to low, the analog write gives you, which is kind of tricky because it says analog, and I know at the beginning of the class I was talking about analog pins, but they are two completely different things here, because the analog write is still associated with the digital pins, not the analog pins. But the analog write gives you the value or the choices of going between 0 and 255. All right? And now the question becomes, why is it 255? Well, because it's a value of 2 to the 8th, which is 256, which has probably some type of 555 timer, or even a, what's the word I'm looking for? Or some type of switching mechanism that's powered by multiplexer. That's the word I was looking for. No, your Arduino should be plugged in. The only thing you have to do is write this code and upload it. And when you do, all right, what you should see is that both pins 2 and 3 turn on to their highest value for about a second. And then when it gets to this line of code, what happens is the pin 2 goes to a low or shuts off, while pin 3, I don't remember, you may or may not, you might need to change this number here. You can play around with this number here to make it a different value, but this is the number that's going to control how high or low you see it. All right, raise your hands when you got that. David, you want to let me know through the chat box. And stop playing around with all the settings. This should be the exact same circuit from the last class. This is, I haven't changed anything about this circuit. I see you, David. All right, raise your hands up when you have it working so I know. All right, while we're waiting, go ahead. You can play around with this number here to see the different effects it's going to have. I'm having trouble. It looks like I have typed it correctly, but it's giving. What error message is it giving you, Jay? Yeah, it's not going to be fading yet, Zach. What you should see is the light on for the brightness of the light should change depending on what you have this number here set to. Yeah, Jay. There you go. What error messages are you getting, Jay?
Expected squiggly, squiggly, squiggly before bracket token.
All right, so you're missing one of these braces here. Do you have 4 braces in your code?
Yes.
All right, let me see your code. Just copy and paste it. Oh, you didn't put a semicolon right here.
Oh, yep.
You do that, and like I said, change the number, and the brightness should change. See, again, pin 2 should be like really bright, shuts off, and then pin 3, the brightness of that changes. So now let's combine what we did last class with what we're doing this class to try to make it fade up and down. I still got you muted. How you coming, Manuel? Did you say you got it? I don't remember. Okay, cool. All right. Put this one down there. All right. So now let's use the for loop to try to make it so that we can actually see the lights changing. All right. So here is our code. Now, if you're really clever, you can just kind of copy and paste around or write the code around this, right? So you don't have to change too much. And then this is the code we're going to set using our counter variable in our for loop here, right? And then right here, these are our limits here. So I'm going from 0 to 256, and then I'm starting at 255, and I'm going down to 0. Now, two things here that I want to point out is the different signs here. And just type as I explain, please. Put hands down. All right. So here I'm just saying the counter is going less than 256, but yet I said 255 earlier. Well, it's because it's saying less than 256, because 255 is the only whole number that's less than 256. If it goes up, another one is actually equal to 256, right? Makes sense. Simple math. So that's why it stops here in this for loop at a line at 255. Now this one here, int counter equals 255, less than or equal to 0, etc. All right. Here we're using or greater than. I don't know. I always get them confused. But the greater than and equals to here I'm saying it's actually going to 0. If I deleted this right here, whoops. If I deleted that, it would stop at 1, which is actually perfectly all right considering the code we're using, but it does give you a little bit of hopefully more understanding. All right, and let me know when y'all have that. And that is void setup up there, by the way. Everything up here is still the same. while y'all are doing that, I am going to see, let's see. Raise your hands when you got it done now so I can see it, or so I can know. All right, if you get it done quite early, like a few people have, make another light do it. Make another light fade with PWM. Make a different color light. My robot voice. Why do I have a robot voice? Do I have a robot voice tonight? I went from robot to Snoop Dogg. Okay. Well, fuck shizzle my nizzle. How do you make it change color? By just switching the pin on the LED. Like if you have a red LED, or if it's in a yellow, just find the pin that's associated with the red one. And do it like that. Or if it's yellow, find the pin that's associated with the red LED and make it do that. That works too. Are 2 pins fading, Mr. Gabe? Then try to make another one fade. So you should. I want you to try. Since you got it done, make one bright, one off, one on, one off, and then 2 of them fade in and out. Simple 3 lines of code, depending on how you have it set up. If you have an error with the code, let me know, and I can try. I can usually spot them pretty quick. And this waveform that we're doing, this is also used in. David says he thinks he can answer too. I might put you to the test, David. Okay, you added that. Now what? You've actually added the pins already by changing the pin mode. Hopefully that's in your void setup. Now what would you have to do to make them fade in and out? That should work. Yeah, that'll work. Manuel, Zach, how you coming? Ooh. All right, what's your error? Send me your code. Or actually, yeah, send me your code. David found his error. All right, to get his code, David, it gets to be a little bit tricky. He just sent it to you. You got to click on it in the question block. All right, click on it in question block, then go up, click somewhere else, click back, and then not in the question block itself, but below it, you can copy all the text from there and then paste it. Oh, found it. I found one. Send me that. You forgot a semicolon somewhere, Gabe. I don't think I got all of your... Oh. Yeah. Manuel, you have two void loops. That's your main problem. That's what was confusing me. So you need to take all of this out. I'm going to add another bracket here. And then you just write your for loops here. In your first void loop. So it'd be here. For I'm going to cheat. There. Bracket. Bracket. And I'm going to get rid of this. Change this to counter. That. You see what I'm doing, Manuel? Then your other part will go right here. For int counter equals 255. Whoops. Counter less than or equal to 0. Counter minus. There. Another bracket there. Change this to counter. And then that should work. Oh, delay here. Oof. That's pretty tricky, Manuel. Oh, somebody else just sent me another code. What did she send me, Gabe? And then that should fix your problems, Manuel. And I'll send you the code here. Actually, here, let me send it now. Here. Copy. Paste. There's the fixed version there, Manuel. Your code was a little bit more in depth. Oh, okay. Gabe, you got it working. All right, cool. What did you do? That works, but you could have just put the counter, could have just put all this here and here. There we go. Put that there. Working way too hard over there, Gabe. Way too hard for a programmer. Delete that. That there. Change this to counter. And counter. There, done. That's exactly what I'm saying. Be more lazy. Yeah, you worked way too hard. What I miss here? Semicolon here. Dave is my teaching assistant right now. Why is it doing that? Did I put a little delay in there? And delay. Yep, nope, that works. All right. So the main point is that the analog right is, even though that you're seeing the light fade, it's actually the same amount of voltage. It's just on for a different amount of time, right? Which is creating what's called a waveform. All right, and waves get to be pretty important in pretty much everything. One, because light is a wave, my voice is a wave. Pretty much, yeah. The study of waveforms led to a whole bunch of other fun things. All right. Now, let's move on to let's change this up and add a different subject. So, how much time do I have? All right. Here I'm going to make this one a little bit easy on you. I'm probably just going to give you all the codes instead of making you the ocean is a wave. Yep. Instead of writing it out here. All right. But I do want to cover arrays. Now, we looked at arrays earlier in Scratch, right? An array is just a list or a selection of things, of data types. When I say data types, data types refer to things like the ints, which we already use, ints, floats, which are decimals, chars, which are letters, and strings too. And you have an array of strings. Like when you're typing out a Word document, you have a bunch of strings, and probably some of those get stored in some type of an array. Or actually, spell checking is a massive array. So this one gets kind of confusing here. I do not like that example at all because that is really weird. All right. So what if? All right. If I was, what the way this is phrased? Array index. What does the array in? Go to 7. All right. The array index part of it. That is the associated value of the array. However, the associated value of the array can be a lot of different things, like a cat, a dog, a bird, a house, a monkey. All right? How large is this array index? What's the total number of array indexes on this one? Good job, David. Good job, Jay. 500,000 worthless internet points to Jay and David. Jay, you haven't got any yet. So Jay and David, not Gabe. Gabe, you're like negative points right now. So there's 8 array indexes showing up on the in this array. Why? Because 0 counts. All right. So when you're talking about array indexes, they go from 0 to 7, and so actually I have a size 8 array for a yeah. Okay, that kind of makes sense. Why does an array start at 0? Because, well, that's just where computers start talking, start communicating. So if I was actually call array number 3 is actually associated with bird. All right. Animal number 5 is monkey. All right. And so you might think it's a cow or a horse, but they're actually two different. There'd actually be one minus 1. Depending on how the code, actually that depends on language too. I have found, which was a headache. All right. So to define an array, and this is going to be a new code. We're going to start a brand new code here. So go to File and New, and I'm going to make your life easy. File and New, and I'm just going to give you this line of code. Copy and paste. All right, so there's the first line of code I want you to have. That's going to be your top line. All right, and what this line of code is doing is, one, we are declaring that we're going to use an array of ints. All right, so the part that makes it an array is these 2 brackets, and ints as in whole numbers, and we're saying 3, 5, 6, 9, 10, and 11. Now, why are we using those particular really weird pins? Well, I'll explain here in a minute. Well, if you look at those pins, hopefully you can figure it out. And here is going to be our void setup. Come on. There it is. Copy. Paste. So there's your void setup for the next line of code. Now, make sure you hit enter. Now, notice one thing that it's doing here that's a little bit different than what we have been doing. So by using this for loop, we are actually kind of cycling through the array. All right. So it's a similar concept of what we've always done as far as the for loops. Here I'm saying counter. Right. So when it's at 0, it goes to 0. It initiates 0 pin, which is 3, as an output. All right. It does not change the value. We're not changing this value of 3. What we're saying is I'm going to that index of the array, index 0, and I'm making it an output. All right, and so forth and so on. So then I'm making pin 10 an output, with pin 11 being the output for the last one. Now, here comes our for loop, or our void loop, I'm sorry. Void loop. Copy, paste, send. All right. Give yourself some space. Make sure you then put this in there. It might copy kind of weird like mine did. Let me fix this up a little bit. That's annoying me. I can't have it like that. All right. Here we're using two different concepts here. That there. That goes there. 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 1 second, I have to fix this. It will drive me nuts. Here. 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 Back this one. Tab. One thing that is a good practice, especially when it comes to for loops, is making sure all your brackets here line up like I'm doing with mine, all my braces. And hopefully if I load this code up, everything works just fine now. Hopefully I didn't change it too much. Yep. All right. Now, a few things with this. One, all your LEDs might not line up because we're using pins 3, 5, 6, 9, and 10. So you might need to adjust your pins, the way where your wires are plugged in accordingly. Avery, dude, you're 10 minutes. You're 10 minutes shy of the class, dude. You want to join the 10 o'clock class? Avery. All right. I'll send you an invite after class. All right. Has everybody got the code and everybody's looking at it and stuff? Is everybody's code working? Okay. So we're doing a few different things here, and I do want to make a special note. So we're doing pretty much exactly the same thing. And again, you might need to change your where your wires are plugged in accordingly to 3, 5, 6, 9, 10, and 11. And if you look at those particular pins, you'll see that there's like little squiggly marks around them. And what those squiggly marks are noting or denoting is that pin is a PWM pin. So it's actually a special pin. Kind of like Gabe is a special person. I put that in quotation marks. All right, here, 1 second, Gabe. I'll get. Nope, not at all. Here's the full code here. I'll just give you the full code. There we go. All right. So here, I'm just going to kind of focus in on this line of code here. This counter, I, or LEDs, pins, counter, and I. Now, before, in the last for loop, one of these was a number while the other one was the counter. Well, here I'm using two variables. I'm using both counter and I'm using the variable of I. So here I'm using counter, here I'm using I. Well, the reason this is happening, or reason I'm doing that, is for two different reasons. Well, I guess one real reason, because I'm using what's called nested loops, all right? In this case, it's a nested for loop. So I have a for loop inside of a for loop. So what happens is this for loop gets executed first of counter, right? So counter equals 0, counter less than 6, blah, blah, blah. So it executes this line of code, and it sets the counter to 0. Then it executes this line of code of our value of I, which is our PWM, right? And then we use that here, all right? So this nested, this is the, when and hopefully all y'all at some point in time take a programming class, this idea of nested loops is the thing that's going to try your soul, and you're going to be dreaming about loops, and it's going to really mess your head up. But if you start getting the concept now, it's actually pretty simple. I don't know. Who's John? All right. It's Mr. Pearson. All right. So here, and again, this nested idea, this here comes just because I've had a few codes that's been like, nested here and here, and if you nest inside of a nest, it gets all kinds of confusing. So it gets interesting. And then you can also take a for loop. You can nest it. We've worked with if statements before, but not really in this class yet, or for the Arduino. But you can nest a if statement inside the for loop, or a if statement, or an if statement, or a for loop nested inside of an if statement. Wow, that's hard to say. All right, so it gets kind of confusing. But hopefully, does everybody see kind of what's going on here, despite all my squiggling and rambling? Did everybody get the kind of understand the concept of a for loop, or not the for loop, the nested loops? And you see hopefully how I'm going from counter to I here, and both of these variables correspond to whichever for loop I'm using. And this one goes up to here, etc., etc. Cool. All right. Erase all the drawings. One more pen. All right. Yeah, I'm not going to use that one. We don't have any green lights, do we? Y'all have green LEDs? I don't think y'all have green LEDs. I just got red and yellow. Do y'all have anything else other than that? Nope. All right, so we're going to skip the traffic light thing. The traffic light thing is easy. You just make the green light turn on, the yellow light turn on, or the red light turn on. All right, hopefully just using digital writing. Just very simple. Well, there you can go for it, make a traffic light. Yep. So I'm going to do something else here with this code. This is going to tie into the next class. Now, this isn't part of the slide, so I only have a few minutes, so you're going to watch my screen here. Some of you have already seen me do this, or at least heard me talk about it. Now, I want y'all to go up. This is the same code. Don't change it too much. Just change it the way I have it set up, and I'll make it easy for you. I'm going to come up here on top of this for loop in void setup. I'm in void setup. All right. I'm going to come down here. I'm going to give myself some space. And I'm going to type out serial with an S dot begin 9600. Let me know when y'all have that. Raise your hands. And I'm in the void setup here. Yes, this part here you're going to have to type. Wait, hang on. A little bit that's confusing me. Is that replacing the plus plus? What's replacing the plus plus? No, this is not. No, this is outside of the for loop. The I still has a plus plus on it here. So this one corresponds here. You know what? Hey, yeah, I know what you're saying, Gabe. I think this makes sense. So just write the serial begin here, and then I'll show you. I think you'll understand it here in a minute. All right, cool. So the serial begins. This is actually going to give us the functionality of actually talking, having the Arduino talk to us through the computer, or us talking to the Arduino. How do I want to do this? All right. So here, and I'm just going to do it inside this first for loop here. I'm in the void loop, and I'm in here this first for loop. I'm going to come right underneath it here. And I'm going to type in serial dot print open parentheses, quotation marks, hello. Semicolon. Or actually, print line. Put an L in right there. And if you upload the code, how much time I got? If you upload the code, and then up to the top right, you'll see serial monitor. And then I should see hello being printed out 10 different times. And that is based off this for loop here. All right, does everybody raise your hand if y'all have that? So then you're missing, either you didn't hit the serial monitor, Gabe, or it's not set to 9600 right here, or this line of code is not right. Right up here, top right corner. You should see a little magnifying glass thing. Cool. How you coming, Manuel, Zach, Andrew? Okay. So that saying hello, that's nice and pretty and all, but it doesn't really help us too much. What I really wanted to do here is we're going to kind of really demonstrate the value of what counter or what the for loop is doing. So I'm going to come here to this line that we just typed, and we're going to change it up slightly. I'm going to get rid of the LN part, because what the LN does is after every time it prints out hello, it goes to the next line, right? But here I want it to say, I'm going to say hello, but instead of saying hello, I'm going to say counter space equals. And then under here, I'm going to put serial.print line counter. Just like that. And then if I upload it, what I should see is the value of counter changing in the actual serial monitor. If I can get it working. And so here, even though I'm printing out the value of counter, it's actually printing out the actual numbers. All right, and I'll cover more of this class, or more about this in the next class. We're going to be talking about inputs and outputs. I just really, because like being able to do this really helps you troubleshoot what's going on I can't remember who it was that stayed after one day where they saw me writing a bunch of stuff where I put this in there. And this is exactly what I was doing. So if I do the same thing here, I can just copy this. And by the way, it's 8 o'clock, so y'all know my rule. Here, I'll put that there. I equals, because I'm inside that I loop, give myself some space, then I. Then we should see an entirely different functionality here. There we go. Now, by doing this, and you have to scroll through a lot here, but you'll see that, let me see, come up here. So here I'm saying counter equals 4, so it initiates the pin number 4, and then it instigates, and then it kind of like jumps all the LEDs up or down accordingly. All right, so that's why you see them turn on and off one at a time versus all together. All right, this is the kind of main point I wanted you to see. The counter of the for loop moving, right? And you see it moving at 2 different rates of speed, one being faster than the other. And that's because the only reason it's slower for the first one is because before the next loop of the counter can be initiated, it has to jump all the way up to 255. And you're missing a semicolon somewhere, Gabe. Yeah. Anyone didn't even say bye. Neither did Jay. Alright, y'all. For now, I'm going to have to bid y'all adieu, and I'm going to get back to my next class. Or get ready for... Wait. Gabe, do you want to come to 10 o'clock? Does anybody want to come to 10 o'clock? It's pretty much the same material. Alright. I will bid y'all adieu for now.